and privacy or security. We will talk about the basics of computer networks, what are the basic terms, what are the devices that we use in computer networks. And then next week, we will talk about network security fundamentals, what are the different things we use for securing our information, and how the privacy is affected when you access websites online, what is intellectual property. So these topics we will discuss in the next week. Today, we will start with the basics of computer networks. So before we do that, first let's talk about what is a network. In real life, we have network of people. For example, we have multiple persons which are able to communicate or talk to each other. That forms a network. Similarly, instead of persons or people for communicating, if we have some devices instead of person or kid, if we have some digital devices which are used in communication with each other, that will form a communication network, collection of devices which are able to talk to each other. If the devices we use are mobile phones, in that case we call it a mobile network. If the devices we use for communication are ATM machines, like in the banks, we call it an ATM network. And similarly, if the devices we use for communication are computer networks, in that case we call it a computer network. If the devices used are our computing machines, our computer systems, that is called a computer network. And in a computer network, whenever a device wants to send information to another device, the information we first divide it into a very small part which is called packets. We transfer the packets from one device to another device in the computer network. But how do they transfer the information? To understand that, first you need to understand some basics, the basic terms which we use in communication. First of all, we have the source or the sender or the one which is requesting information. For example, you are at your home and in your mobile or in your laptop, you enter the address gmail.com or you open the Twitter app. So when you do that, you are basically the source. You are sending a request to the Twitter website or to Gmail or to Google website, and those are your destinations. Twitter server or Google server, that is your destination. So we have a source and we have a destination from where we are requesting the information. And how they are connected through what we call communication links or simply links, and also they are also called channels or communication channels. So these links or channels, they interconnect these devices. So in this diagram on the right side, the computers are connected using these black lines. These black lines are your channels or links. In real life, these black lines, what do they represent? They can be a wired connection, like your network cable. But can these lines represent also wireless connection as well? What do you think? Or is it for
Yes.
fixed? Yeah, it is for wireless also. So these links that you see, they can be wired and they can be wireless also. Then, if I want to go from source to destination, let's say this is my source here, the first top left computer, and the bottom right one, that is my destination. If I want to go from source to destination, I will have to go through different links. I will have to go through different channels. And the channels that I go through from source to destination, that will create something which is called a path. What is a path? It is a collection of links that connect the source to destination. So, simple question, do we have a single path from source to destination, or do we have multiple paths available?
Both are
Multiple.
possible.
Multiple.
We have Yeah, we have multiple paths available, and we should always choose the one which is the shortest. We need to find out the shortest path from source to destination. Now, to transfer this information from source to destination, there are multiple ways. There are two ways basically that were used. One was used in early days, which was called basically circuit switching. That was called circuit switching. Now, before I further move ahead, this networks topic, it will be used in quiz number 2, and also it will be part of the final exam. So make sure you understand it properly. Once again, quiz 2, which will be at the end of March, and final exam, both of them will use this week 7 and 8 material. So try to understand it properly. So anyways, now to transfer information from source to destination, one method is called circuit switching. In circuit switching, what we do is we first find one path. There are multiple paths available. First, we decide on one particular path. Let's say I decide on this straight path here. From this computer, I go straight down, and then I take a right turn and I reach my destination. So let's say I have decided this path. So in circuit switching, what I will do is I will first make this path completely private. I will make this path private. That means when the source and destination are talking to each other, no other device on the network can use any link on the path. So these links on the path, they will become completely private. No one else is allowed to use these links. So it's like a completely private communication. So obviously this will be good for the security. So it's a good thing that we are not sharing, we are just making it completely private. So it's a good and secure way to transfer information. But it has a very big problem. The problem is, if I want to compare it to real life, these links or channels, you can think of them like roads, the roads which are interconnecting different locations together. What the circuit switching will do is it will make the path private. That means I want to go from, let's say, from KFUPM, this is my Khubar destination. What circuit switching says is that make the roads private. That means when I am driving on the road, no one else is allowed to bring his car on the road. The road can carry a lot of cars, but when I make it private, no one else is allowed to enter their packets, their cars on that road. So do you think this is good? Are we using the links efficiently in circuit switching method? What do you think?
No.
No, we are not utilizing the links properly. So to solve that problem, we use something which is called packet switching. So in packet switching, what we do is, if let's say this host one is our source, this is our destination, the packets, I don't tell the packets that, okay, this is your path. No, I just tell the packets, this is your destination. Go find your path by yourself. That means the packets are completely independent. So first thing, packets are independent. They find their own path. Why? I will tell you in a few seconds. Second, most important property of packet switching is we can now share the links. When we share the links, that means these roads can now carry packets, they can carry the cars of not just a single person, but anyone can bring their car and utilize the road. They can use the links more efficiently now. So here once again, packets from different sources, they can now share. They can share a single communication channel. They can share these lines now. So that's a one major advantage. That is, we are now utilizing our resources, we are utilizing our links properly. But what will be the disadvantage of doing that when we are sharing?
I think it will not take the shortest link.
Shortest path they can find. The problem now
No
will be
privacy.
the privacy or the security, because that means when the packets are going through the same links, maybe there is some hacker, maybe let's say this node E is of a hacker, and he can maybe capture the packets and open them. So there is a problem of security in packet switching networks, but it's not a big problem. Why? Because we can secure the packets also. For example, when you access websites, you see in the beginning at the top left, do you see this HTTPS?
Yes.
The
Yes.
S part here, the S part here, there are two ways, two types of protocols. I will talk about them, but here we sometimes we have HTTP and we have HTTPS. The one with the S, what it will do is before we send packets on the network, it will secure the packets. We will encrypt. We will talk about encryption next week. We will secure the packets in such a way that even if there is some hacker in the middle somewhere, even if he captures our packet, he will not be able to open them. That's the main thing of doing the encryption. He will not be able to open the packets. He will not be able to see what is inside the packets. So that's the advantage. So we can basically solve the security problem using better encryption. So we'll talk about encryption next time. But one major advantage is we are fully utilizing the links. So that is listed here also. Steady stream of packets will take the full advantage, the optimal, the best advantage of the carrying capacity of the channel. That means if the road can carry, let's say, 100 cars, when I'm sharing the road, that means I will be trying to utilize the maximum capacity of the road. If it can carry 100 cars, when we are sharing, it is a possibility that we will maximize the usage of the road. Similarly, if the links can carry, let's say, 1 GB of information, when we are sharing the links, we are actually trying to fully utilize these links. Our efficiency will improve now. Do you understand this point, everyone?
Yeah.
The stream of packets will take the optimal, the best, the full advantage of whatever the capacity of these links is. But just like in real life, what happens? We are sharing the roads, yes, but sometimes we actually reach the full capacity. What happens in that case? In real life, what happens in that case?
Crowded.
It's crowded. We have traffic jam. In case of computer networks, this traffic jam is called congestion. We say the network is congested. And it's not a difficult problem. We can solve it also. That is why the first point I told you, we make the packets independent. We don't tell the packets that, okay, this is your only path. We just tell the packets, okay, just find your path. Wherever you want to go, you can go. Why? Because we can have congestion. And how to solve the congestion? Just like we do it in real life. Let's say I decided to go from KFUPM to Khubar, and I decided to use the Khubar Dahran highway. But if I reach the intersection, let's say this is the intersection and this is the Khubar Damam highway, I see there is a traffic jam. What will I do in that case? Will I enter the traffic jam or I will change the direction?
You will change the
You will
direction.
change the
That is exactly why we make the packets independent. We tell the packets, okay, go find your path. So the packets, although this one looks like the shortest path, do you notice that? This looks like the shortest path to the destination, but the packets are not entering or going through this path. Why? Because there may be some congestion here. So the packets have the ability, they are independent, they have the ability to change their path also. Do you get the idea? How we resolve the congestion problem? Understand that, everyone?
Yes.
Yes.
Okay, so that is your congestion, and this is how we can solve it in packet switching. So computer networks, they use this method which is called packet switching. Now, there are different types of computer networks based on different properties. Based on the network size, there is wide area network, local area, intranet, extranet. Based on how we manage, we have different type of networks. We will only talk about these two properties. There are other ones also. How the network is formed. We have mesh networks, star networks, bus networks, and many other types. But we will only focus on two type of management. One is the type of computer network based on the management. We have first one which is called client server network models. In the client server model of managing your network, we have all the devices of the network. They are connected to one single centered device. They are not interconnected with each other. They are only connected to one central system. We call it a centralized system because they are all connected to one central device here. That device is basically called your, that is called what? Your server computer. And all the devices which are connected to the server, those are basically called your clients. So we store all the information of the network on the server, and the clients will request information from the server. Remember, this client server network model, it's just a model of management. It doesn't talk about the power of the computers. In week 2, when we were classifying computers, we talked about the desktop computers, we talked about the servers, the mainframes, the supercomputers. You remember that?
Yes.
Yes.
Here, here, the server, here the server means the system which is the central part of the network. It doesn't mean that the computer which is more powerful. Yes, it will be more powerful, but this server here, it can be a normal server, it can be a mainframe also, depending on how many clients you have. I'm just talking about the model of managing the information in the network. For management, if all the information is in the central system, we call it a client server model. Most of the internet websites, they use this client server network model, like Facebook, Twitter, Instagram, all these websites. The client's data is stored on their main computer systems. We can call them a centralized system, the server. The clients are spread throughout the world, and they can request their information from the server at any time. So that is a client server model. And it gives you a centralized system. Centralized means all the information of the network is in one central point. That is your server. Now, can you tell me some advantages of doing this, of the client server model? Why do we use it a lot? What do you think are the advantages?
You can control the network.
You can control the network. Okay, yeah, you can say that.
Right. Right.
Also, we don't need to worry about the storage. If there are clients, the client, for example, as a client, you don't need to worry about storing your Facebook data, Instagram, Twitter data on your computer system. The server will handle your storage. Different cloud services like iCloud, that also follows the client server network model. Your information is in their server. Whenever you want, you can just request the information. You don't need to worry about storing your information in your computer system. It's in the cloud. So that's another example of client server model. What about security? Do you think it is easy to implement security or difficult?
Difficult.
If we talk about securing the whole network, so if I have, let's say, 10,000 clients and let's say one server to handle their requests, to handle their data, to provide security, should I focus on all the 10,000 computers plus the server, or should I just focus on the server only?
The server only.
The server only. So security is basically easy to implement here for the network. I'm not talking about the computer itself. For the whole network, the security is easy because I just need to focus on one device. So basically, I can put all the security protocols, everything, I can just focus on one computer. So in this way, it will be much easier to handle the security. Now, what do you think about the disadvantage?
Slow.
So we can solve it. We can purchase a higher speed connection, but yeah, we can say it can be a little slow. But all these centralized systems, they have one major problem. We call it basically they have something which is called a single point failure. What's a single point failure? That is, if somehow in the network there is one device, if that goes down, the whole network is lost. It is gone. Which device is that one in this type of networks?
The
Servers.
server.
Server.
Server. Exactly. So, for example, if the server somehow shuts down, the whole network will be lost. That means this type of model, it has a single point failure. That's what I mean by single point failure. But how can I solve it? Since it is very commonly used, what should I do if, let's say, this device shuts down, something happens, what should I do as a administrator? This is
Backup.
my, what should I do?
Put another server or backup server.
Backup. So we have backup servers, exactly. If one server shuts down, I can switch to the backup server and fix the main server. When it is done, I can put that server back online. That is one way to solve it. So it's not a big issue. So that is client server model. Another model is called the peer-to-peer network model. This is the complete opposite of the upper one. That is, it is a distributed and decentralized system. That means there is no central part of the network. Every device is connected to every other device in the network. There is no central part of the network. Every device can send information, every device can receive information. So to provide security in this type of network, I will have to focus on all the devices in the network. So security here will be easy or difficult to implement?
Difficult.
Difficult. It will be difficult to provide security in this type of network because, and they are basically not secure. In general, peer-to-peer networks are not secure because we cannot provide security for like thousands of computer systems at the same time. It's very difficult. Okay, so that is peer-to-peer network models. But what will be the advantage? The advantage will be the opposite of the client server disadvantage. Client server disadvantage was single point failure. But here, all devices are connected with each other. Even if one device shuts down, if let's say this computer shuts down, it's okay. The rest of the network will still remain connected. And everyone is sharing the information. That means they need big storage also. So we need more storage here as well. And how the communications work, this type of networks, they are used, for example, in torrent networks. If let's say this computer, the first top left one, if it has one new file, a software or a game or some music, it wants to share. So what it will do is it will announce to its neighbors. It will announce that, okay, everyone, I have a new file. So it will share it with the neighbors. The neighbors will get the file and then the neighbors will broadcast. It will announce, they will announce that, okay, we have a new file, and then their neighbors will get the file, and then after some time, all the network will have the same information. So that even if one computer shuts down, it will not affect the system because the system already has all the files. You get the idea?
Yes.
That
Yes.
is peer-to-peer network model. It is used in torrent networks, it is used in sensor networks also, wireless sensor, biological sensor networks, we use them also. So that is peer-to-peer network. So this is how we manage, the two ways to manage the networks. So another type of computer networks is based on the coverage, based on the size of the network. We have the local area networks and we have the wide area. So local area are the smallest. They connect computer system in a very limited geographical area. In your home, in a lab, in a KFUPM building, a small lab that constitutes a local area network. And these local area networks, they can combine, they join together to build a large network, and the largest of that is called the wide area network. It covers large geographical regions like the whole world. Internet is an example of wide area network. So once again, local area is the smallest one. And the local area networks combine to build bigger networks, and the biggest one is the wide area networks, for example, the internet. So once again, we have the local area network and the wide area network. Local area is the lower limit, WAN wide area network is the upper limit. Between them, we have two more types. They are called intranets and extranets. So both of them, they have one thing in common, that is intranet and extranet, they are bigger than local area, but they are smaller than wide area network. So once again, both of them, they are bigger than local area but smaller than wide area network. But what is the difference between them? Between them, the difference is based on the privacy, or you can say the security. Intranet Intranets, they are completely private network. They are completely private networks. No one from the outside is allowed to access the intranets. It's a completely private communication. No public website you can access within an intranet. We have some private organization, some security organization to manage the employees for internal communication. You can use intranets. Military, as an example, military, they can build their own intranets for internal communication. They don't want the enemy military to infiltrate, to basically go through their own communication, so they can build these intranets for internal communication. That is intranet. What is extranet? It is similar to intranet. That means the internal communication is still completely private, but it has some access to the outside. It has some connections with the public networks. That is extranet. As an example for extranet, for example, we have the KFUPM network. The internal communication between the buildings, between the departments, our own internal network, all of that, that is completely private communication. That is just like a intranet. But if a computer in the KFUPM network wants to go to Gmail, Gmail is a public website on the internet. So when it wants to do that, what we have now is that in the ITC building, we have some connections to the internet, to the public network also. So that When we want internal communications, we will use our internal private network. No one will know about it on the internet. To the internet, it will look like we have just one computer here because we have just one link to the internet. And here, when any computer wants to go to Gmail, it will send the request to the ITC building, and from there it will be forwarded to the internet. So the internet will think that we have only one computer, but internally we have a whole network. Internal communications are completely private, but it has some connection to the internet for public communication. That is your extranet. So once again, intranet, this is an intranet, completely private communication. But when we include one extra connection that connects it to the internet, then it will be formed as a extranet. Do you get the idea, everyone?
Yes.
Okay, so
Yes,
that
yes.
is extranets. Your virtual private networks, the VPN services you use, that is also an example of extranets. They have their own private networks throughout the world that are connected to the internet. And when you connect to any virtual private network, you become part of that private network. And when you want to go to the internet, they will show you that identity that you are using in that VPN. They will not show your true identity, your true address of your home network. So they will hide your identity in this way. So virtual private networks, they are also an example of extra nets. And once again, both of them are bigger than local area but smaller than wide area network. Any question related to these, anyone? Yes.
Some doctors in the campus use the VPN to access to some files.
Yeah.
So is this uh, related to this?
Uh, that is KFUPM's own VPN service basically, because the VPN service that they are providing, because if we want to access the internal communications of the KFUPM, for example, there are certain websites within the KFUPM, the portal, the e-business, okay, the business intelligence, BI, those are basically for internal communication only. And at the faculty housing that we have here, or their own internal internet that we have, for example, we have purchased STC connection, that is part of the public internet. So to provide access to those individuals of the internal parts, they have built up a private network also, that the public users can join and become part of KFUPM network. But of course, it will require authentication, the passwords of KFUPM on portal, some extra two-level security. They will require you to join that virtual private network to access the private parts of KFUPM network. Okay?
Okay, thank you.
Yeah. So that is intranets and extranets. Now, what are the devices that we use in computer systems? To connect to computer systems, they can be connected once again in a wired or in a wireless method. And for that, before I talk about before I talk about that, so first let's talk about network node or host or endpoint device. So these are the devices which we use to connect to the network. They are also called endpoint devices because we use them at the end of a network connection. At the end of a network connection. For example, in my house right now, I have the Wi-Fi, STC Wi-Fi network. The devices that I will use to connect to that network, those are my endpoint devices. I can use my laptop, I can use my smartphone, I can use the desktop computer. So these are all my network nodes or hosts, or I can also call them endpoint devices. And how do they make this connection? They use a hardware device which is called the network interface card. This is a hardware device which is used by the endpoint devices to connect to the network. So in case of your laptop or in case of your desktop computer system, if you are connecting using a wired cable, so the spot where you plug your cable, it has basically a network interface card inside it. That card is responsible for transferring the data from your endpoint device to the network device, to the network. And these cards, they are not only for hardware for the physical connection, there are network interface cards for wireless communication between your endpoint device and to the network as well. So these are your network interface cards. So they provide network connection between the devices. That is network interface card. Next, we have one of the most important part, one of the most important device in computer networks, that is our router. So I will take a 3-4 minutes break. We will resume at 4:15. So we will talk about router next. So you can take a breather and we will resume in few minutes. Yes, question.
Yes, doctor. Can I turn off the camera because it has been almost 5 minutes and I can't see the presentation. He just keep telling me that I have a weak internet connection.
Ah, okay, no problem.
Thank you.
So I will start again at 4:15. You can take a drink. So let's resume. Yes, what's the question?
We have a break now, right?
We'll just resume in 2-3 minutes, okay?
Fine, fine.
Okay, everyone. So let us resume the presentation. So we talked about the basics of computer networks, and we talked about different devices that we use. But now I will talk about the most important part of a computer network, that is the network router. So this router device, you have seen it many times. When you purchase a connection from STC or any other company, they will give you a small rectangular box like this one that we have seen in the bottom right corner. And this device you normally use to connect to the internet. So this one, that is a very simple and small network router. It has many properties. First of all, a major property of this router is to manage and build a network. So when you plug this router in your house, it will build your internal home network. So that management, that construction of the network at your home, that is the responsibility of this router device. Second property is interconnecting networks. So I told you here that local area network, these are the basic small networks that connect devices in a small area, in a house or in a lab. And these local area networks, they interconnect, they connect to form bigger networks. So how do small networks interconnect with each other? How can I connect one building network to another building network to another building's network and so on? So this interconnection between the networks is done using, once again, the network device, which is called your router. So when you are sending a packet, when you are sending information from source to destination, you are passing through many networks. For example, the source is your STC network. The destination is, let's say, your Google or Gmail network. So when you go from source to destination, you have to go through many networks. And these interconnections that you see here, these interconnections, these are not simple computer systems. These are basically your routers. The circles here, they represent routers. So this is your home, your host computer system. It is connected with a network to your STC network. And STC network has many interconnections with other networks in the internet. So when you go from source to destination, these interconnections are done using these routers. So the routers are the ones which are interconnecting one network device to another. They are connecting one network to another network to create bigger networks throughout your internet. So one major property of the network of the router is to interconnect. So once again, first one was to manage, to build and to create a small network. Second was to interconnect one network to another network. The basic router that you have in your homes, it is doing two things. One, it is creating your home network, building that. Second, it is interconnecting your home network with the STC network. So it can only interconnect two networks, your home network with the STC network. But the advanced network level routers, the network level routers, for example, like this node E here, this is another router. They can interconnect not just one network, but they can interconnect 3, 4, 5 networks together. So that is another property of router, that is interconnecting networks. The router symbol that we use in network diagrams, this is the network symbol that we use for the router, and it is interconnecting different networks. And then the third one, the third property of a router, it comes from the name of the router, that is routing information. I told you once again in the same diagram of packet switching that the packets will go from source to destination and they will find their path. So basically, the packets have absolutely no idea how to find the path to source and destination. They have no clue. What the packets do, what we do with the packets basically is we just write down the destination. We say that, okay, this is your destination. You have to go to Gmail. And it's basically the responsibility of the routers. So when the packet goes to the router basically will look at the destination. It will see that, okay, this is the destination of this packet. So based on that destination, the router will find the shortest path. So for routing, for finding the shortest path from source to destination, that is also done by the router. So three major properties of the router. One, managing or creating the network. Second, interconnecting between networks. And third one, the routing of information from source to destination, that is finding the shortest path. So for example, let me show you here in command prompt. In the command prompt, if I type a command called traceRT space gmail.com, so that will basically find out the path from my computer to gmail.com. So that will basically trace the path from my source computer to the destination computer. So that will show the address of all the networks that we encountered from my source, from my computer to the destination, that is the Google network. So this path, the address, I will explain in a few minutes. But basically what I'm trying to say here is when you go from source to destination, you have to go through many networks. And who is responsible for finding the shortest path? That is the responsibility of the router. Do you understand that, everyone? Yes, question?
Will the router find the shortest way to the next router or to the destination?
It will find the shortest way to the destination, and based on that, it will find the next router. What do I mean by that? For example, let me show you here. For example, if there is a router here, the router will look at the packet and it will see that the destination is this one, and then it will check and calculate the shortest path from here to the destination. It will see that, okay, it's maybe this path, maybe this path, maybe this path. Whichever is the shortest, it will forward it to that router. And that router will again calculate. It will check that, okay, what is the shortest path now? It will again check that, okay, this link, it will see that, okay, this is congested. So the shortest path is maybe this one or maybe this one or another one. So it will again update the shortest path. So that's how every router on the network will calculate the shortest path every time. Why do you think every time we need to calculate? Why don't we just calculate the path in the beginning and just let it forward? What
For
do you
the
think?
congestions.
Exactly, because of the congestion. Because with time, the network, the links, their activity can change. That's why on every router is calculating the shortest path, just to make sure that the path which was decided in the beginning, is it the same shortest path or not? Maybe the network changed its property, maybe there is congestion now. So that's why every router is calculating the path every time we cross it. Okay?
Okay, it's clear. Thank you.
Yeah. So that is your, once again, router. So it can have wireless and wired connections as well. Now, Another thing we have in computer networks that is called the communication protocols. So protocol, just like in real life, what is a protocol? It is a set of rules for communication. We are living in the pandemic age right now, so we are also following certain protocols. You want to go to the mall, there are certain protocols you have to follow. You have to wear the mask, you have to show the Tawakkalna app now. So the protocols, these are the set of rules for communication. Similarly, in computer networks, we also have many protocols. I have two devices which are connected using a wired cable. They will follow a certain protocol for communication. They are connected using wireless. They will follow a different protocol. And then within wireless, there are many types. Wi-Fi will have a different set of rules. Bluetooth will have a different set of rules, different protocol. And these protocols not only depend on the medium, they also change when the communication type changes. If, for example, two devices are communicating using the web pages, we will use these HTTP or HTTPS protocols. If they are transferring files, we will use FTP. If we are transferring emails, it will use a different protocol, SMTP. If we are doing video call, that will use a different protocol. If we are doing audio call, different protocol. So the protocols will change depending on the type of communication as well. And each type have further types inside it, depending on the security. HTTP is the normal hypertext transfer protocol. It is a protocol set of rules to transfer hypertext. To transfer hypertext means your web pages. And what is HTTPS? It is the more secure version of HTTP protocol. So protocols, they have further types. Some are secure, some are more secure, and so on. Then the most important one from these protocols is the TCP/IP protocol. TCP stands for Transmission Control Protocol. IP stands for the Internet Protocol. So what this protocol provides you, it gives you rules for identifying every device on the internet. This TCP/IP protocol basically says that it is used to identify every device on the internet. It says that whenever you connect any device, so not every, it says basically that every device on the internet must have a unique address. Let's say you want to go to your friend's house. You want to go to your friend's house. You need his address before you can travel, right? You will ask him that, okay, send me your address so that I can reach your destination. I can reach your house. That is the address. We call this address the IP address. I will talk more about this IP address in a few minutes. But before we talk about TCP/IP, let's look at the management which is done in the internet. So the internet, once again, I told you it is a network of networks. It's a network of many, many small networks. They combined together to build this large network that is called our internet now. And these networks within a country, they are managed by something which is called internet service providers, like STC, Mobile, Zan. So these are the companies that offer a network to the individual users within a country, and they are managing that network. And these ISPs of different countries, they are managed by what we call network service providers. They are responsible for providing the network service within a certain region, Middle East, Europe, North America, South America. It's managed by network service providers. And they use what is called network access points to interconnect. For example, Middle East network is connected to Europe network, then it is connected to North America or South America using these network access points. So these NAP and NSPs, they basically form something which is called the backbone of the internet. And these large companies like AT&T, Verizon, they are responsible for managing this backbone of the internet. And that is why they charge the customers when they give you internet access. They charge you because they are maintaining the backbone. They're making sure that the network connectivity is available throughout the world. If there is a cable failure, they are responsible for fixing it, for managing, for upgrading, for providing you better services. So all of that is done by these companies, these network service providers. So that is how the management in the internet will work. Then, what is the web? That is World Wide Web, WWW. It's a collection of all these websites or web pages which are accessed using a protocol that is called Hypertext Transfer Protocol, HTTP. And the secure version is HTTPS. So a website or a web server is a computer that stores the web pages. Web pages are made of hypertext, and they are transferred from the source to destination using the protocols that is HTTP. So if you want to build a website, you will first create the web pages in your computer. You will send them to the web server. You will make the web server online. So now anyone on the internet can access your site. They can access your web pages now. So that is your web server. I will talk about URL in a minute, but first I will talk about the IP address now. So we are back to this very important part of our lecture, that is the TCP IP protocol. So I told you it is a protocol which is used to identify every device on the internet. And this protocol says that every device on the internet must have a unique address. This address is basically called the IP address. The IP address. And it is different from the ones we have in our real life. If I want to tell someone my address, I will say that, okay, apartment number, dot, some apartment number, building number, this, and so on. KFUPM, Bahran. So this is how we write the address. We provide the PO box, we write the apartment number, building number, things like that. But computer networks, they are made of digital devices. We are using digital devices in the network. And their identification should also be based on digital addresses. So when we talked about bits, you remember a bit can have two possible states, that is 0 or 1. Do you remember that, everyone?
Yes.
Yes, Victor.
So we have bits 0 or 1. So if I have one bit, I can have two possibilities. I can have it as 0 or I can have it as 1. I can say that when the bit is 0, that is the address of my computer. When it is 1, that is the address of, let's say, another second computer. So one bit is definitely not enough to address all the devices on the internet. If I have 2 bits, how many addresses I can have now?
4.
4. That is equal to 2 to the power 2, which is equal to 4 addresses. So I can give address to 4 computers on the internet now. Obviously, it is not enough. In the first week, when we were talking about bits, we wanted to represent characters, A, B, C, 1, 2, 3, like that. But here I'm using the bits to represent addresses, address of computers on the internet. At that time, when we wanted to represent characters, where did we stop? We stopped at how many bits during that time? We thought that 8 bits were enough. You remember that? And we
Yeah.
called them byte. But here, if I have 8 bits, I can have how many different addresses? 2 to the power 8, which is
8.
equal to 256. So on the internet, do we have 256 computers only?
No.
No. That means we need more bits. So basically, there are different versions of this IP address. First one that started in the 1890s, that was called IP version 4. This uses 32 bits for the address. The size of IP version 4 is 32 bits. If it is 32 bits, that means how many addresses I can have? 2 to the power,
32.
that's a large number. So we can have a lot of addresses in this way. So I can ask a question. What is the size of IP version 4 address? You will say 32 bits. If I ask you what are the total addresses possible in IP version 4, you will say 2 to the power 32. So once again, this is the size. This is the total number of addresses possible. Do you understand that, everyone?
Yes, it's clear.
Yes. So how do we represent this address? How do we show these 32 bits? The problem is if I want to, because once again, we are communicating in this open world. And if I want to tell someone that, okay, I created a website and my address is 10100010, something like this for 32 times. Is it easy to remember? Is it easy to communicate?
No.
No, obviously no. So we need a better representation of the 32 bits. Remember, the hardware will receive 32 bits, of course, because hardware can understand. But for us to make it easy to communicate, to represent, we need a better way to show these 32 bits. So a better way to represent these 32 bits is to divide them into 4 segments, 4 parts. If I divide them into 4 parts which are separated by a dot, so we have second part, third part, fourth part. So we have 4 parts. What will be the size of each part?
1 bit.
8 bits.
8 bits or 1 byte. So basically, once again, each part is basically of 8 bits. This part is 8 bits in size, this is 8 bits in size, this is 8 bits in size, and the last one is also 8 bits. Now, the question remains, how do I represent these 8 bits as well? So how do I represent these 8 bits?
By numbers.
By number. So which number scheme? There is also possibility we can use real numbers, we can use positive integers, we can use negative integers. There are different possibilities. So we decided to use whole numbers. Whole numbers basically are positive integers, that is 0, 1, 2, 3, and so on.
255.
Yeah, so that's my next question. So when we have, listen carefully everyone, we have 8 bits in each segment, right? So when we have 8 bits, we can have how many different possible values? That is 2 to the power 8, which is equal to
256.
but the values I am starting them from 0. What's the maximum number I can have in each segment? 256 or 255?
55.
255.
255.
Exactly. So basically, each part of this segment can have a number from 0 to 255 dot 0 to 255 dot 0 to 255 dot 0 to 255. So that is how we represent IP version 4 address. I can ask you a question here. I can say that, okay, which of the following is a correct IP address or IP version 4 address, to be very precise? Which of the following is a correct IP version 4 address? First one, what's the problem with this one?
The first one.
Above 255.
258. That number is greater than 255, so it is wrong. Second one,
Yeah. The last
260.
part. Above
260 is greater.
255.
Yes. So second one is also wrong. Third one,
Third one is correct.
third one
Correct.
is
There is no
correct.
problem.
Yes. Fourth one, what's the problem with the fourth one?
The third
1100.
100
The
more.
third part here,
100.
the third part, that is 1100, that is wrong again. So that is once again IP address. So every computer on the internet will have this address. So back to that same router property, that is routing information, finding the shortest path. So basically when you send a packet on the internet, you write down the source and destination IP address. The routers, how do they find the shortest path? They basically look at the address. They look at the IP address and they find out that, okay, this network is maybe in this router's path, so go in this direction. Then they'll say, okay, this network is in this direction, okay, go in this direction, and so on. The trace path, the trace RT command that I showed you, the trace RT command that I showed you, it was going from one network to another and finding out the shortest path. So they are using IP addresses. So where are we? Yeah, here. So that is IP version 4 address. We can have total 2 to the power 32 addresses. They are divided by periods into 4 segments. And each segment can have a number from 0 to 255. To check the IP address of your computer system, you can type a command called ipconfig /all. Don't worry, this command is in the slides. I will show you after 2-3 slides. This command, that is ipconfig /all. It will show you the IP configuration of all the network devices in my computer system. I have some virtual machines, so that's why it's showing me other ones also. But here you can see for my gigabit for the network, the local area network connection, you can see here my IP version 4 address is listed here, 192.168.100.2. So that is IP version 4 address. But now I will talk about the next one, which is IP version 6. So IP version 6, why do we even need IP version 6? The problem is we are running out of space in IP version 4. Initially, we decided that 32 bits will be enough. But recently, the number of devices on the internet, they are increasing because of this new concept, that is Internet of Things. Anyone heard about this Internet of Things idea? What is that? This idea basically says that every device, not only computing systems, your every home appliances like your light bulbs, your kitchen appliances, your washing machines, every device in the future will be part of the internet. And to be part of the internet, remember once again, to be part of the internet, we need to give it a unique address. Do you agree? To identify, we need to give it a unique address.
Yes.
So means we need more addresses. So we are running out of addresses in IP version 4. That's why we are now slowly shifting to IP version 6. IP version 6 uses 128 bits for the address. The total addresses possible are 2 to the power 128. That's a very, very big number. Some countries like Korea, Japan, China, they have already shifted to IP version 6. Here in the kingdom, there is also some companies which have shifted. They provide this IP version 6 address. Yes, question?
Why there is no IPv5?
That is, I can't answer like that. It's just basically how they implemented it together, because between IP version 4 and version 6, there were ways to deal with the increasing problem of this number of addresses. To deal with that problem, they proposed two different ideas. One was called the dynamic IPs, and the second one was called private and public IPs. So during that time, although IP version 5 were proposed, but they were not accepted and publicly accepted, because these two ideas, they handled the problem of increasing number of IPs. But with increase of number of devices further, we are not able to fully utilize, we are not able to fully address all the devices. So that's why we are now slowly shifting to IP version 6. Just to future proof ourselves for the next 40-50 years, to make sure that okay, we will not run out of space at all. So that's why we increased it. Instead of 32 to 64, we increased it to 128 directly. So the problem why we cannot easily shift from IP version 4 to IP version 6 is, to shift it completely, we need to replace all the routers, all the protocols, and that will take time. That's why the shift is slow, but in few years, almost everyone will have IP version 6 throughout the world. Now, let's talk more about IP version 6, its properties. So IP version 6, it's the next generation of IP address to replace IP version 4. Once again, total addresses possible are 2 to the power 128. And its division is different. It is divided into 8 segments. It is divided into how many segments? 8. What will be the size of each segment in that case? If I have 128 bits divided into 8 parts, what will be the size of each part? What do you think? Very
Is it
simple.
1
16.
byte?
128 divided by 8.
16.
The size of each will be 16 bits. And these 16 bits, we will not use whole numbers or any other number. We are using hexadecimal system for them. So it's a different way of representing numbers. You will study this in mathematics course later on in engineering. So I will not go into details, but I will just show you how it is represented. So hexadecimal numbers are here, and each segment is separated by a colon. Instead of a dot, it is separated by a colon, and we have a total of 8 segments. We have 1, 2, 3, 4, 5, 6, 7, 8 segments. But the general representation of IP version 6 is basically that if we have 0 segment in the address, we can replace it with simply the colon characters. So if I give you an address like this, I can ask you that, okay, how many 0 segments this IP version 6 address has? You will first check how many segments it has already. We have 1, 2, 3, 4, 5, 6. So we have 2 missing. That means these 2 double dots are representing the 2 0 segments. So you can say the answer is we have 2 0 segments in this IP version 6 address. Similarly, if I give you an address like this in the quiz, I can ask you that, okay, this is an IP version 6 address. Can you tell me how many 0 segments this address have?
2,
four, four.
So we have
yes,
four
4.
segments. Yeah, so we have four segments, 1, 2, 3, 4, and the remaining 4 are zeros. So that means the zero segments are basically 4 here. So the zero segments are 4. So that is how you will answer this type of question. That is IP version 6. Now, one more thing about IP version 6 or IP version 4. One more thing is that although we have made this representation now for version 4 or version 6, the problem is still, is it easy to memorize? If you want to tell your friend that, okay, I made a website, my address is 204.127.129. Maybe 144, is it easy to memorize?
No, no.
So we need some character representation. We need some character representation, and that one is basically called the domain names. You want to go to a website, you don't type 192.11.15. Something. No. We type this gmail.com, Twitter or Facebook.com. What are these things? These are basically called the domain names. The .com part, that is the domain. The Gmail, that is the name of a website. Together, they are basically called domain name. There are different type of domains. We have .com, we have .edu, .net, .gov, and so on. And we have these different type of domains. And one more thing was, I skipped this slide, where that is URL. What is URL? It is a uniform resource locator. It gives you the complete information about a web page on the internet. It tells you about the domain name, the server name, the protocol, the folder, and the exact name of the web page. If I give you a URL like this, I can ask you, what is the domain name in this URL? That will be yahoo.com. Some web servers, they have separate servers for different type, for files, for videos, for pictures. So we have files.yahoo.com, video.yahoo.com, and so on. So this first part, that is called the server name. I give you a URL and I can ask you that, okay, what is the protocol used in this URL? The protocol which will be, which one?
HTTP.
HTTP. So it's a very simple type of questions I can give you in the quiz. I give you a URL and I can ask you that, okay, what is the folder name? You will say current contest. What is the file name in this URL? You will say rules.html. So that is your URL. Now, to talk about this conversion, so basically that means I am typing this gmail.com. The computer understands these addresses 11.12. Something like that. That means we need to convert the names into addresses. Once again, before we can send the packet on the internet, remember always that when you send the packet on the internet, you need to write down the IP address of the destination. But in the host, what are you typing? Are you typing IP address of the destination? No. We are typing the domain name. That means we need to convert domain name into IP address first. So basically, when you send the request from your router to the STC or your ISP, that request will not directly go to the internet. It will go to another part of the internet. I can put it here. Let me put some shape here. So I can put another shape here like this. This other part of the internet, that is called the DNS system, the domain name system. And the group of computers that handle those requests, those are called DNS servers. DNS servers. When you send the request, of, let's say, gmail.com, it will not directly go to the internet. It will first go to the DNS servers. What do DNS servers contain? It is like a library. It is like a library of domain name and IP address. You will have like gmail.com. Okay, this is the IP address 10.15.11. something. Sorry, not 321 obviously. And then we have other domain name, their address, other domain name, their address. So it's like a table. So when you enter a website's domain name, your request first goes to the DNS servers. They will return the IP address. And now the ISP will put the IP address on the packets. It will write down that, okay, the destination address is this. And now it will send the packets on the internet. And on the internet, we will have many routers. They will look at the IP address and find the destination network. Do you understand that, everyone?
Yeah.
Okay,
Yeah.
that is your DNS. You can check also. There is a command called nslookup space the name of a website. So this command basically will go to the DNS servers and just get the IP address. It will not go to the website, it will just get its address. So if I want to get address of which one you want, anyone? Let's check for Gmail. I want the address of gmail.com. So if I say nslookup space gmail.com, I press enter, it will give me the address here, that is gmail.com. It is giving me two addresses. What are the two addresses? Why not one? What is the first one for?
Version 6.
Exactly. So it is giving me two addresses. One is IP version 6, second is IP version 4. So do you think I can access this? I can use this address on the internet instead of typing the domain name? Can I
Yes.
access a website directly from this address? Let's check. Yeah. It basically takes me to the Google main server. From here, I can go to Gmail and so on. This is the Gmail link here. So that is, once again, we can access the websites through the IP address also. So that is your DNS system. And the routers, now I will talk about one thing that I was telling you before, that is to solve, meanwhile, while we are shifting from IP version 4 to IP version 6, we needed to solve the current problem. Instead of completely shifting, because it will take time, we need to replace the hardware. So we needed to deal with the current problem of IP version 4. To solve that problem, we found two solutions. One was dynamic IPs, second was private and public IPs. So dynamic IPs, they can help us with the limited addresses of IP version 4. How? For example, if I'm a company owner, let's say STC, and I have 50,000 customers in the eastern region. So I want to give IP address to every device in that region. But the question is, do you think all 50,000 customers will be online all the time?
No.
No. So I can make some analysis. I can check that, okay, maximum, after the analysis, I can say that maximum 20,000 users were online at any given time. What I will do is, instead of getting 50,000 IPs, I will only get 20. And what I will do is, when one computer turns on, I will give him an IP address. And when the computer shuts down, I can give the same IP address to a different customer. And when that customer closes, I can give that IP, the same IP, to a different user. And during that same time, if the old user came back, I can check if its old IP is already used by another client right now, I can give him a different IP. So I'm giving him IPs dynamically. There is no fixed IP for that user. So basically, home users, they get dynamic IPs to deal with the limited addresses of IP version 4. But what do you think about another type of IP that is called static IP? Static IP is something which is fixed, an IP address which cannot change. Where do you think we will need static IPs?
Company, maybe.
Companies or websites. You have to make sure if I'm building a website, I need to make sure my address doesn't change. It's not like you can announce to customers that, okay, everyone, today my address will be 10.11.12.15, and then tomorrow it will be 11.15.20. Obviously, it will be a problem, okay? So you cannot build a website based on that. Your address keeps changing. That's not possible. So static IPs we need for servers. We need for servers and these websites. So this was one way to solve the problem of limited IP version 4, dynamic and static IPs. And in home users, the router also has a protocol which is called DHCP. That is Dynamic Host Configuration Protocol. This protocol is used to assign dynamic IPs as well. It is used to assign dynamic IPs. For example, the same command which I ran before, that is ipconfig /all. Where is that command? Yeah, this command. If you see here, this is my IP version 4 address. Then it says here DHCP enabled, it says yes. So that means I got this IP dynamically from my router. It also says lease obtained. I got this IP on 19th of February. So it's like 10 days before. The lease expires, this IP will expire on March 3, or if I restart my computer system. So that is your IP version 4, that is your static and dynamic IPs. And once again, these are the commands I was telling you. ipconfig /all. I think in the slide there is no space, so make sure you put the space here. ipconfig /all. You can type it in command prompt. To open command prompt, you can just simply type cmd here in the search bar. You can type cmd and open command prompt and check your IP address. Similarly, the ns lookup command which we use to get the IP address of a website, we can use that as well. Similarly, we have trace RT to trace the path from source to destination. So these are the networks that we encounter from our computer to gmail.com. So that's another thing. And then we have bandwidth. What is bandwidth? Anyone? It's the capacity of the internet connection. Capacity basically means how many bits the connection can carry in 1 second. You can check your bandwidth from speedtest.net. So if I run it, I think ran it before, but it's not here. So let me just check here from speedtest.net. If I go to speedtest.net and run the test, it will basically check my bandwidth. It is measured in bits per second, that is BPS. Mega is definitely the higher unit. And then there are two types of bandwidths. One is called the downstream. The second one is the upstream bandwidth. What's the difference between downstream and upstream? What do you think, everyone?
Now that the data you get from the internet up
Exactly.
is the data you inserted in the internet.
Yeah, the data that we send towards the internet, that is upstream or upload. And then we have another property here that is called the ping. What is the ping here, anyone? It says ping 2 millisecond.
for the servers.
Yeah, it's the time to send a packet and then the packet comes back to your computer system. How much time it takes from the nearest server from STC. How much time it took? It took 2 milliseconds to send and get the same packet back. That is the ping. Do you get that, everyone? So
Yes.
that is basically your bandwidth. So difference between IP version 4, domain name, and DNS. So try to answer these questions. I will stop here. Next week, we will talk about private and public IP. So this is a very interesting thing. I just showed, we talked about the basics of computer networks. We saw how information is transferred in a computer network using packet switching. We saw different type of computer networks like client server and peer-to-peer networks, and then based on the size of the network, we saw that we have wide area, local area, intranet, and extranets. So intranets, they were completely private networks. And if we add one connection to the public internet network, then the intranet will become extranet. Do you understand that part, everyone?
Yes, doctor.
Okay. So this will be important. We will use it again in today's lecture. So keep that in mind. And then we talked about the devices. We talked about the host or endpoint device. And then we talked about the most important device in computer networks. That is our router. So router, it had multiple tasks. It is used to manage or build the network. It can be used to interconnect one network with another network. And it was also responsible for routing the information. That means finding the shortest path from source to destination. And then we saw we have different protocols which are used in computer networks. And protocols are basically set of rules for transmitting and receiving the information. And the most important protocol that we talked about, that was the TCP IP protocol, the transmission control protocol. It assigned IP address to every device on the internet. So IP address is a sequence of numbers that uniquely identifies each computer on the internet. We talked about IP version 4, we talked about IP version 6, and then we saw that to solve the limited addresses of IP version 4. So remember once again, IP version 4 had limited addresses. To solve that problem, what we did was we started first of all with dynamic and static IPs. So static IP is an IP which is fixed. Dynamic IP is one which is changing, which can change depending on the situation. So do you remember dynamic and static IPs, everyone?
Yes.
So once again, the IPs that you receive at your home, the local customers, do we receive static IPs or we get dynamic IPs?
Static.
No, we get dynamic IPs. So once again, if for example, STC has 50,000 customers, let's say in the eastern region, so we can make some analysis and check how many of them are online maximum at a time. All 50,000 will never be online. So what we did was we did some analysis and we check that, okay, maybe 25,000 or 30,000 are maximum online. So instead of getting all the 50,000 IP addresses, we only get 25 or 30,000, and we assign those addresses dynamically. When one computer or one customers turn on their computer system, we give him an IP address. When that customer shuts down the computer, we give the same IP address to a different customer. So that is dynamic IP. Static IPs are used for websites. When you want to build a website, you don't want to change the address. You want the address to remain fixed. So that's why we use static IP for website and servers, and dynamic IPs for customers, for users. Is it okay?
Yes, doctor, but in the dynamic IP, what if there is
Mhm.
more than 50,000 users? What is going to happen?
What do you mean more? No, we will do the analysis based on the number of users. Okay. Just wait. The second way to solve that problem will basically help further resolve the IP version 4 problem. Okay. So this was one method to deal with the limited IP version 4 addresses. Another method is called private and public IPs. So this is a new another way to basically resolve the problem of IP version 4, that is using private and public IPs. So what is private and what is public IP? Before I talk about that, once again, let me remind you, IP version 4, the address is written in this format, that is 0 to 255 dot 0 to 255 dot 0 to 255 dot 0 to 255. So that is the range of IP version 4 addresses. That is like a total capacity that we have. So in private and public IP, what's the idea? If I run that command, that was ipconfig space / all. If I run this command on my laptop here, I'm in the KFUPM network right now. So here I get this IP address, this one. My IP address is 10.57.15.213. So let me write that IP address here. So this is the IP address that I received. Now, if I do the same thing, I ask Google, what is my IP address? If I ask Google, what is my IP address, just type my IP address and check on this website, what is my IP address? I get this address, 37.224.7.12. So is this IP address similar to one that I am receiving in command prompt?
No.
No. So
No.
there is something wrong here. So one of them is a private IP, the other one is a public IP. So what is private IP? What is public IP? I will talk about that now. So let us get back to the intranet extranet debate. So intranet is a completely private network. Okay. Now, if I provide one connection to the internet in this intranet, it will become extranet. Do you agree?
Yes.
Okay. Now, that means, listen carefully now. That means when any computer on the intranet wants to go to the internet, it will use this connection to the internet. This connection to the internet means that on the internet, every device will think that we have just one computer because we have just one IP address here. Internet will think that, okay, we have just one IP address, one computer in our network. That IP which we represent to the public network, to the public internet, that IP address is called public IP. That IP address is called public IP. Public IP. Just like when I asked Google here, what is my IP address? It said this is my IP address because this is my public IP. Just like here in this diagram, KFUPM is working in the same way. We have many departments. Many departments have computers inside. But when I make a request on the internet, it goes through this external connection here. This point where we connect to the internet, then and the address that we have here, that is our public IP address. Is it okay?
Doctor, can more than one device use the same public ID, IP?
Exactly. They not can, it will. Every computer, for example, here, if I take KFUPM example, all, let's say KFUPM have, let's say 5,000 computers, and all 5,000 computers, their information is going through this public IP. They are all using this address, this public IP address, this one. Because to the internet, we have just one computer. But the problem is, if I want to do internal communication, because you see this computer, both of them, their public IP is the same. Do you agree?
Yes.
Yes.
Yes. But the problem is, if I want them to talk to each other for internal communication, I cannot use the public IP for internal communication. So for internal communication, we need some unique addresses also. So those addresses which we use for internal communication, those are our private IP addresses. So the first one that we received in the command prompt, that was basically our private IP address. Now, one more thing, can the private address that I use for internal communication, can I have the same address in the internet IP addresses?
Repeat your
No.
question.
No, because if I have an address which I am using for private communication, if I have that address in the internet address book, the problem will be if one computer wants to go to that computer, it will be confused. Am I talking about the IP address in the internet or the one in the internal network? There will be problem. So what we do is, for private communication, we will remove the addresses from the total internet IP version 4 addresses. These are the total addresses we have. So what we do is we remove some addresses. We remove some addresses from the internet here to use them for internal communication. And we make a rule that we will not use those private IPs on the internet. So we basically remove the addresses from this full address space that we have. So what are those address ranges? Those address ranges are this one. First one is 10, although the first digit can be any number from 0 to 255, but the numbers which are starting, the IP addresses which are starting from 10, and the next three parts can be any number from 0 to 255, 0 to 255, 0 to 255. This is our first address range that we will use for internal communication. That is one range of private IPs. Another range we take out, we remove it from the full IP version 4 addresses is this one, that is the number starting with 172, and the second part of the address can be any number from 16 to 31. The last two parts can be any number from 0 to 255. If the IP address falls in this range, that will be a private IP. And then the third range, which should be very common, you should know that you use it in your home also, that is 192.168 range. The first two numbers are 192, the second one is 168. The next two numbers can be anything from 0 to 255. So these three IP address ranges we take out from the full internet IP version 4 addresses. We remove them to use them for private IPs. And anything outside these ranges will be our public IPs that we will use on the internet. Okay, so here this is for large networks, the first one. The second one is for medium-sized networks, and the last one is for small home networks. Just like you see at your home. Anyone, have you seen in the command prompt or in your network settings, your local IP address will be like this, 192.168. Have you seen that address,
Yes, doctor.
router? So that is for small networks. But my question is, our whole idea of private, public, or dynamic static, our purpose here was to basically somehow increase the size of total addresses on the internet. Somehow we should be able to deal with the problem, because IP version 4 was very limited. We needed more addresses. But right now, from the internet, the total internet addresses, by dividing them into private and public. Public IPs are the one which we will use on the internet. By doing this division, are we increasing the total addresses on the internet, or have we reduced them basically? What do you think?
We reduced them.
We reduced, we removed these addresses. In fact, we have basically made the IP addresses further lower basically. That's not what we intended to do. We wanted to somehow increase the capacity of the addresses that we can have. There must be something wrong here, or we have to look at more carefully. So let's look at it more carefully now. So let's go back to this diagram here. Now this diagram. So this is, once again, I'm in private and public IPs. These are the private IP ranges. What is the point of removing them and using them for private networks? The point you will see here now. So let's see. Let's say we have here, this bubble is for KFUPM network. We have many computers, 1, 2, 20, 1,000, 2,000 computers, and they have internal IPs, private IPs for internal communication. And KFUPM has one connection to the public internet. That is our public IP. You agree, everyone?
Yes.
Yes.
So this is
Yes.
our public IP. These are our private IPs. Any computer wants to go to the internet, it will use the public IP. To the internet, we have just one computer. Internet, any computer on the internet has no idea what is inside here. And similarly, let's say I have another network. Let's say this is KAUST University's network. They have their internal computers, they have their internal IP addresses, and they have a public IP also. So when any computer on KAUST University wants to go to the internet, they will use this public IP. So my question is this. My question is that when any computer in the KFUPM or KAUST University network, when it goes to the internet, it will use the public IP. Agree?
Yes.
Yes. Yes.
That means a computer in KFUPM has absolutely no idea about the private IP address of a computer in KAUST University. For this computer, the address of this computer will be basically the public IP of the network to which this computer belongs to. Do you agree? For me, basically this computer address is the public IP because I don't know what's happening internally in Chaos University. Do you agree to that?
Yes.
Yes.
Yes, and the same goes in the opposite way. A computer in Chaos University will have no idea what is the internal address of this computer. So my question is this. Listen carefully. My question is this. When I took these three ranges out, IP version 4 addresses have been reduced. And this is not what we intended to do. But my question is this. Can two different networks like KFUPM and KOUST, can they have the same private IP ranges? That means a private IP addresses which I'm using here in KFUPM, can I use the same range in Chaos University network? Because when each of these computers go to the internet, they will use the public IP. So for internal communications which are completely private, no one outside knows about them, can I repeat the private IP I used here? Can I repeat them in this network also?
Yes, you can.
I think
Yes,
you can.
yes. And now this is basically the main trick. The trick is that although I removed these addresses from the internet, I removed them from the IP version 4 addresses, but the advantage I gained is that now I can reuse these address ranges as many times as I want. I can repeat them as many times as I want, and by doing that, my overall address space will increase. How? Let's do another example. Let's say I want to build a network. Let's call it. In fact, maybe there is some. Oh, I will talk about this netting in a few seconds. But first, let's say I want to build a company. Let's say ABC. It has 10,000 computers. Before having private and public IP, what I would have to do is from the internet, I will have to get 10,000 IPs. Do you agree?
Yes. In
Yeah,
the
I would
internal.
have to get, yeah. If there was no private public idea, then I will have to get 10,000 IPs. But now what I can do is no need to get 10,000 IPs from the internet. I will just get one IP. I will get one IP from the internet. I will get only one IP. And internally, I will build a private network that will use private IPs. This one, the ones that we took out already, to build and to manage the 10,000 computers. Whenever all of them, they want to go to the internet, they will use the one public IP that I got from the internet. Similarly, if I want to build another network for a different company, let's say XYZ, and I also want 10,000 IPs for that network, then again, instead of purchasing 10,000 IPs, I will only get one IP from the internet. The rest will I will internally manage. So when I wanted to build two networks, the total devices needed were 20,000, and basically I needed 20,000 IPs. But by doing private and public IP separation, what happened is that private IPs, they keep getting repeated without any problem. And the public IP, I will only get two. I will only need two public IPs to build these two networks. And in this way, by repeating the private IPs multiple times in many networks, the overall space of the internet addresses have now increased. That is why this standard of private and public is used throughout the world now. Do you understand this, everyone?
Yes.
Yes.
Okay. So
Yes.
one more question is how, for example, this is the public IP of this KFUPM. These are the private IPs. When a packet comes from the internet back, let's say you requested something and it came back to the network, it came back to KFUPM. How will the packet know that it needs to go to this computer or any other computer? Because the packet came back to this public IP, because to the internet we have just one computer, right? They
Yes.
don't know what's happening internally. So that is why at this network administration level, at this exit location, in case of KFUPM, the ICTC department, the administration of the computer network, they will do something which is called netting. So the routers there at the administration, they will do something which is called network address translation. So before they send packets on the internet with this source IP, before they send packets from different users on the internet, they will first here, the routers here, they will write down, they will create a netting table. They will say that, okay, this private IP, this computer, that is user one inside our private network, he requested this website, let's say ig.com, with this user ID and with this pass, whatever it is, with this information, he requested that. Then he will write the second user's private IP, and it will type that, okay, this the second private IP that we have, this one, let's say he requested, give me another website, let's say he requested twitter.com, and this whatever the data is from that website, he requested this information. So that when the packet comes back from the internet, it will come back to this address, and this is where our main server will be. So when the packet comes back, we will look at the packet here, the administration part here. It will look at the packet and it will see that, okay, the packet is coming from this website with this ID and password. It's coming from this website with this information. That means this packet is for this private computer here. So it will forward the packet to this one. Do you understand how this translation will work, everyone?
Yes.
Yes.
That process is basically called netting, that is network address translation. So it is just done by the network administrator. So that is our public and private IPs. You need to memorize these public and private IP ranges. If the first number is 10, the rest can be any number from 0 to 255, that will be a private IP. If the first number is 172, the second number is anything from 16 to 31, and the last two can be anything from 0 to 255. That will be also a private IP. And if the first two are 192 and 168, the last two can be any numbers. That will be also a private IP. So I can ask you questions, multiple choice questions in the quiz of computer networks. That, okay, which of the following is private IP, which of the following is public IP, like that. First one, what do you think? Is it private or public?
Private.
Private, because it starts with 10. Second one,
Private.
private. You see, it starts with 172. This is okay, private. The second number is 17. 17 lies between 16 and 31. So that means it is private. The last two doesn't matter because it is 0 to 255, 0 to 255. So that is Private. What about third one?
Public.
Public.
Public, because
Public.
the second part is 15.
This one.
15 is not included in this range, so that means it is public. Third one or fourth
Doctor,
one?
doctor.
Yes.
Public. Is 16 and 31 included?
Included, yes. 16 and 31 are both included in this second range. Okay. So this fourth one?
Public.
Private.
Public.
Oh, public. You see, second part is 33. It is greater than 31 here. 16 to 31 will be private. Anything out of that range will be public IP. So this is also a public IP. What about the last one?
Public. Private.
Public. First part is 192. Second part is 167. It has to be exactly 168 to be a private IP. Okay, so that is public and private IPs. Is it okay, everyone?
Yes.
Yes, question?
Doctor, in our homes, is the router doing NAT in AT?
Exactly. The router, yes, exactly. The router is doing netting because at homes we are using this IP range. Which one we are using at home?
The third.
This one. Yeah. So the router is doing that for us. If we have like 10 devices in your home network, the router is doing the netting for you. Okay.
Okay.
Now, next, I will talk about network security and privacy. So there are many principles in network security. The idea of network security is to protect a network from increasing cyber threats. And how to protect? There are many ways. One method can be to provide secure access to the users within the network. For example, if you enter KFUPM, you will see if you want to join the KFUPM wireless network, you will have to provide your student ID and password. So it's like an extra level of security. Similarly, we can secure or provide encryption to the user data. We will talk about encryption in a few minutes. Not only user authentication, we need to secure the data on our networks as well. We need to make sure that whatever techniques we are using, they will secure the data which is sent on the Wi-Fi or on the wired network. Most part of it is the responsibility of the network administrator. The firewall, it is a software which is used to provide the security. It's the most important part for network security, that is the firewall software. It is responsible for providing the secure access, for securing the user data and all these things. And also another responsibility of the network administrator is to educate the users. KFUPM ICTC department, they keep sending us emails about any new threats, any new ways that the people can access your information. So they will run security campaigns. Is it okay, everyone? This is just a basic introduction. So first, what we will do is we will see what are the different type of threats we can have in computer systems. So first of all, I will talk about malware. So what is malware? It is any program which is designed to anonymously, without your knowledge, enter your computer system, and then it can affect it in many ways. It can corrupt the files, it can delete the files. So there are many ways these malwares can affect your computer system. And they are of many types. We have viruses, we have Trojan horses, we have worms. So here I will not talk about how virus or a Trojan horse is designed, how it is created. For that, we will need basic knowledge of Python or JavaScripts like that. We need to understand the programming and how it works. But What we will do is we will see their properties, how a virus works, how a Trojan horse works on your computer system. So first, let me talk about a computer virus. A computer virus, first of all, it is not an independent program. It is not like a separate software. No, it is always attached to an executable file. Remember executable files? We talked about them in week 2. It contains the main software instructions. So viruses, they can trick you. They can show that on the desktop it is word.exe file. You can think that, okay, maybe it is Word file, but maybe that executable file will have a virus attached with it. You download some email attachment without checking for virus inside, you just open it, that will be problem. So first of all, they are not independent. They are always attached to an executable file. Second, very important property is that the computer viruses, they require user interaction. User interaction means if, let's say, I download a virus file from the computer, from the internet, somehow it came in my computer, but I did not open it. Do you think my computer will be affected? What do you think?
Yes.
No. It requires user interaction. User must open the virus infected file at least once. Just one time it needs to be opened. And that's where the third property is, that the virus can make copies of itself and then spread. After that, it's not under your control. Yes, first time when you download the virus file, even if you let the virus file stay in your computer for 6 months, 1 year, no problem. But it only needs to be opened or double clicked one time, just one time. You open it one time, and after that it will start affecting your computer system. It will start making copies of itself, and then it will start spreading throughout the computer system. It can destroy the data, delete particular type of files, it can display messages, and so on. You understand that, everyone? 3 main properties. One, it is not independent. It is always attached to an executable file. Second, it requires user interaction. We have to open the file at least one time only. And after that, once it is open, the third property is that it can make copies. It can replicate. It can spread by itself. That's where the real problem starts, when it starts spreading throughout your system. For example, there was this Shamoon virus in 2012 that infected different servers in Saudi Aramco. The user's data was leaked. And how the virus worked, it captured all the data and then sent it to the remote server. It sent all the files there, and then it basically formatted the C drive, the main drive which contains the Windows operating system. It formatted that drive. So all the systems became useless. They had to install the whole partitions again. They had to install the Windows and everything, but the data was also lost. So that is very threatening. You have to be very careful with computer viruses. Now, another type of malware, Trojan horse. Trojan horse has the exact properties of a virus, except one thing. The only difference is that the virus can make copies of itself. The Trojan horse, it cannot make copies of itself. The rest of the properties are the same. That means it is also attached to an executable file. It also requires user interaction. I have to open the file to be infected with the Trojan horse. But once I close that file, it will stop affecting my computer system. That is how Trojan horses work. It will only affect your computer system while that executable file is running. And that's why most of the pirated softwares and games, they contain these Trojan horses. They can be used for different purposes. They can give remote access to the hackers. They can be used for mining on your computer system without your knowledge. For example, you download a pirated game. The cracked executable file can contain a Trojan with it. So what will happen is that when you open that game file, the game will start playing. So in the front end, you are basically running the software, you are running the game, you are playing the game. But in the background, it may contain Trojan that will be using your computer's resources. It will be using maybe your CPU or GPU for mining, for extra work, without your knowledge in the background. So if normally the game requires maybe, let's say, 20% of CPU usage, 30-40% of the graphical processing units usage, the Trojan infected malware that will be utilizing more resources, and that can happen. So most of the pirated content, it contains these Trojan horses, so you must be very careful. Yes, there was a question. Anyone?
Yes, doctor.
Yes.
Yes, Doctor. One day I saw this virus in my Huawei phone, and I just deleted.
Mm-hmm.
So is it harmful for my phone or something like that?
No, if you did not open it, then it's fine. Just like also, you see on WhatsApp sometimes you receive forwarded messages that, okay, open this link to win this lottery or win a free ticket to this and this. You've seen that, right? Messages like that. So be careful not to open such type of messages. They may contain some malware inside it. Okay?
Doctor,
Okay.
Yes.
how could you find it if you download a program or something? How could you know if there is a Trojan horse or a viruses?
Yeah, exactly. That's why we have this next that is called the antivirus software. So, and they have something which is called signatures. So I will talk about that. Just give me 2 more slides, okay?
Okay,
So
doctor, I have a second question.
yeah, okay, sure.
The Trojan horse and the viruses,
Yeah,
are it programmable, like some
yeah, yeah,
people make it?
exactly. Obviously, all these malwares, all of them, they are made by people in programming languages.
Okay, how could they do it?
Oh, you have to learn the programming languages first, basically for that, how to program, and based on that, with the executable file, they attach a certain binary code. So basically, when you are writing programming languages, you write what is called a source code first, and then you translate it into machine code. Translate to machine code, which is binary. And in this machine code, basically, this 1.0 format, we can attach it to the certain executable file of a software or of any software, basically. We can attach it to a picture maybe and send it through an email so that if he opens the script inside that file will start running. And once it starts running, you can write code to basically maybe do a certain task, access a certain parameter of the windows and start deleting the files. You can include whatever commands you want, you can write it in that source code. Okay.
Okay, it would take long time to learn all of this.
Uh, Not long time. You just need to understand the basic programming language, any one of them, C or C++ or Python. Once you learn that, you can start developing that. But
Thank
don't go in that route. We are not here to encourage this. Okay.
you. Okay.
So, yeah. So that is virus and that is Trojan horses here. Then another type of malware, we call it a worm. A worm is very interesting. You can even try that in computer networks course. You can try to develop worms, and they are very interesting things. They are completely different from a Trojan horse or a virus. First of all, no user interaction is required. You don't even need to double click or open a worm file to be infected, first of all. So that means no user interaction. It is a completely independent program by itself. So it does not require any user interaction. That's another very important thing. It cannot make copies, just like Trojan, it cannot make copies also. The only requirement for a worm is that you must be part of a network. It will only spread from one computer to another through a network. If you are not part of a network, you cannot be infected by a worm. And their use is different. Trojan horses and viruses, they are used to basically target a certain individual, your computer system, a certain file within your computer system. That is their target. But worms, they are basically used to target websites, to target servers. For example, a very common type of worm is called the denial of service attack. You can build this in Java or in Python using the network libraries. You can make packets by yourself. But here in denial of service attack, what you do is, if let's say I have a website server, you know the IP address of that server. So what you can do is you can write a program that will create maybe infinite amount of packets and just keep sending them to the server. The server will be busy handling the requests of all those packets that you are sending. It will keep handling the requests that you are sending. In this way, the service for the other users will be denied. That's why we call it the denial of service attack. The normal users, when they try to access the website will be slow because the server is getting attacked by a denial of service attack. If you are the server, if you are on the network administrator side, how can you prevent it? It's very easy. What do you think? If you are getting attacked by a certain IP address, he is sending you infinite amount of requests, what will you do?
Close the internet.
Block him.
Block him, simple. I can make a rule. Denial of service attack can be easily avoided by building a rule that, okay, if I am getting more than 5 requests from the same IP address, I can set up a time period that, okay, in 5 seconds, if I'm getting more than 5 requests, that means maybe that computer is trying to attack me. So I will just block the IP. It's very simple to avoid. It's not that difficult. But nowadays, the difficult one is called the DDoS or the DDoS attack, that is distributed denial of service attack. In this attack, what happens? If I want to attack a certain target, I will not start sending millions of requests directly. No. I will first find computers on the same network, the ones which are using that server or using that website. I will first try to capture those computer systems, their IP addresses, and then from those locations, I will start sending the messages to the server. And now the server will be confused that, okay, I'm getting a lot of requests, but they are not from a single IP. They are from all around my network. The attack now will be distributed. That is why it is called distributed denial of service attack. And this one is very difficult to avoid. Normally the servers, they will just wait out until the attack is finished and then they will resume to normal service, or sometimes they can shift to a backup server while the main server is being attacked. So that is denial of service attack. That is another worm. Stuxnet computer worm, that was also used to target Iran's nuclear program in 2010. And how that worm worked? It basically entered that network, and the program was designed to basically increase the pump speeds inside the facility. So when the pump speeds increased, they reached a certain limit and they even exceeded that, so that the pumps basically started breaking up, and that basically caused explosions. So that was another type of computer worm. So they are very common also, but the main thing is they require a lot of resources also, especially like the denial of service attack. You need to have a very strong, very fast computer system and a very strong internet connection also, so that you can send these millions of requests to the server. If your network is not strong enough, then maybe the server will be able to handle, even if you are sending a lot of requests, he will be able to handle it and no problem. So your own resources are also required in this type of computer worms. Another type of threats we can have in malware are called blended threats, in which we combine these different types. We can combine Trojan and a virus, worm or a virus. We can use Trojan horse to get remote access and then plant a virus in your computer system, and when you open it, you may be infected permanently. So we can make combinations also. There was this WannaCry ransomware attack few years back, and how they did that, they basically attacked a certain computer system by first they were encrypting, they were changing the files of your computer system first. So when you go to your C drive or D drive, there will be nothing there. You will just get this message that okay, all the photos and videos have been encrypted. To get the password, to get the files back, you need to send a certain donation to this Bitcoin address. So that is another type of malware that used to be happening in the last 2-3 years. So now we talk about protection. We talk about protection for these different malwares. We have antivirus softwares. They are designed to basically find out and remove these malwares, remove these threats. And we have many companies, many softwares like McAfee, Symantec, Kaspersky, Avast, and so on. But their fundamental working procedure is based on something which is called a signature. So all these companies, whenever there is a new threat on the internet, what they do is they create a signature of that new malware. They identify the threat and they create a signature. Signature is a small bits of information which is used to identify that particular malware.
Like the people.
Yeah, and they send these signatures to their softwares. When you update any antivirus software, you are basically updating the signatures. And a collection of these signatures are basically called a virus definition. So basically, you can use any antivirus software, it's fine, but make sure you keep updating the virus definitions. If you don't update the virus definitions, any new malware, your antivirus software will not be able to identify. So what antivirus software is doing is it is scanning the file. It gets a file and check the signature. It checks all the different signature. Is there a match in any of your files? If there is a match, it will report it. And the signatures basically contain all those viruses or Trojan horses. Their signatures are present there in that definition. So they are just doing comparison that, okay, this pattern, it belongs to this signature, this pattern belongs to this signature. So if any of the pattern is found in your files, it will report it to you. Do you understand that?
Yes.
Yes, question.
Yes, doctor. Why there is no a free antivirus software?
No, there is. There is,
But
I think,
you need to
Avast
subscribe or
was
something like that.
free. Even Windows Security Essentials is also free.
Windows is not.
Yeah, but it's, yeah, you can say it's not that good. It's not properly updated, but still the main thing is common sense. You have to be careful. Don't open some, if someone is asking you to, okay, check this new virus software or check this new, whatever it is, we have to be careful when you are opening email attachments and things like that. Just scan them a little bit before. Don't click on the advertisements that you see on the internet. When you attach a USB, make sure you scan it first. So just do the basic stuff correctly and hopefully you will be protected. I am not using any antivirus software and I have not been affected for like 3-4 years now. So, but once again, you have to be careful when you open emails, when you open website links. Don't click any advertisements. You have to be careful. Use ad block softwares. For example, I'm using, which one is that? Ad block plus. So you can use that, include these extensions in your Google Chrome.
Have you get trapped with a virus or Trojan horse?
What?
Have you ever
Yeah, of course. Before,
faced
yeah, Windows 10 has much better security than before. Windows XP and Windows Vista and Windows 7, they used to have a lot of viruses inside. Whenever you install, you connect to the internet, immediately you will get some sort of threats. Most of the time, it will be targeting specific type of files. Sometime a virus will delete all the PDF files or all the picture files in your drives. But there are ways. As soon as it happens, you should reinstall the Windows, but don't install anything in that particular drive. You can recover the information also. So there are many ways to basically deal with that. It depends on how your computer is affected. Okay. Yes. Question.
Doctor, is lockdown behave like a virus?
No. It's not behaving like a virus. The lockdown browser you're talking about, right?
Yes, because some students said that their computers
Reported
attack.
as a Trojan. Yeah, I know that. The reason is basically the lockdown browser is basically stopping certain activity of the Windows. For example, it's not allowing you to open any other file or go or take screenshot, things like that. Okay. And to Windows, sometime Windows will think that, okay, maybe it's trying to attack or change its behavior. Okay, so that's why it can report it as a Trojan sometime in some softwares. But the latest version, if you update the lockdown browser, they updated that, so it should be fine now. Okay.
Okay, it's clear.
Yeah. So virus signatures now. So that is your antivirus software. So now remember, antivirus software is for your internal threats. Threats within your computer system. If you have downloaded a file and it has some problem, it will protect you from that. For network level protection, we have another type of software which is called firewall. Now, last semester there were some exams which you have to take physically. You had to come to KF UPM, right? You came to KF UPM, right, everyone? You have been here once at least?
No.
No, not yet.
Yes.
Hopefully you will be here soon. So in any case, when you come to KFUPM, you will see there are different security gates, right? So firewall software is like a security gate for your network. Whatever goes out of your network, whatever comes into your network, it goes through that security gate. So firewall is like a security gate. Whatever goes out, whatever goes into the network, it will be analyzed by the firewall software. So it analyzes the flow of traffic going in and out of the network. It will guarantee that the incoming information was requested. So that means, let's say a packet is coming from the internet, okay, and in the firewall it will check which computer in my internal network requested this. If no one requested, what does that mean?
Maybe it is a virus.
Maybe it is virus, maybe someone is trying to attack. So based on that, what the firewall will do is it can generate intrusion attempts. It can block that IP address. So these are the things it can do. It can protect, for example, different countries. We have different regulations that certain websites are not allowed. So to block certain websites, to block certain IP addresses, I can make rules in firewall software. And then what the companies do, STC, even KFUPM, you have not been here yet, but hopefully when the pandemic is over, you will see that in the student housing, all the network in KFUPM is managed by the network firewall in the ICTC department. And they have set rules for managing the limit of the connection. For example, if KFUPM have like 2 gigabit connection to the internet, it's not like they will give full bandwidth to every user. No. They can limit. They can set that, okay, every student is allowed to have a maximum download speed of, let's say, 16 megabits or 20 megabits. We can set those rules in the firewall software. I can set the monthly download limit also. I can set that, okay, every IP address within our KFUPM network is allowed to download a maximum of 100 gigabyte per month. I can set those rules. I can set time limits also. I can set that, okay, from 12 a.m. in the night to 8 a.m. in the morning, there should be no network for any student. I can set that rule. So the firewall software is basically for, you can say it's like a main part of a computer network. If you are building a local network, you must have a good and strong firewall. Computer systems, even Windows also have their own firewalls, but those are very basic level firewall. You can just set up the limits that, okay, this website is allowed, this is not allowed, this is allowed. You can do some very basic level of control in that firewall. But the real one is the network firewall, which is used to control the data limit, to control the speed limit for the users within the network, to secure the users, to protect them from any intrusion attempts on the internet. Your firewall should be strong. Is it okay, everyone?
Okay.
Once again, these are the properties. It can limit the flow of data. It is essential for the computers which are connected to the internet. So that was related to the basic security. Now I will talk about privacy. So what is privacy? It refers to your personal information. And we need to make your personal information secure on computer networks as well. So there are different ways to secure the information. We can use cryptography techniques. I will talk about them. But sometimes you have to be careful how the information is used, who the information is shared with. Some companies like Facebook, like Instagram, like Google, they share your personal information, but it is not without your knowledge. They tell you when you are signing up, they tell you that, okay, we will share your information to give you personalized ads. Right now, there is a fight between Facebook and Apple because the next update, I think 14.5 maybe, they are enforcing that the users should be allowed to choose if they want to get personal ads or not. In that case, Facebook will not be allowed to basically track your personal information. And they are now making different ways to tell the users that, okay, personal advertisements are good for you, you get better advertisements in that way. So anyways, when you sign up, you agree to these things, so you have to be careful. It can be used to track the customers. Google can use that. Based on your location, it can track your location, and based on that, if you go on a trip, you will start seeing different advertisements related to tourism, to hotels and things like that, because they are tracking your behavior, tracking your movement. So you have to be careful when you are using those services. Nothing is free, basically. So you are paying a price. The price is basically yourself, your personal information. But to some level, you can at least secure the information when you are sending it on the network. For example, when you are sending your credit card number or your personal whatever information, your ID and password on the internet, you need to make sure that no one on the internet captures your information. You remember in the beginning when I told you that in packet switching, to protect the packets when we send them on the network, we need to do something about that, right? Because there may be a hacker sitting in between the network somewhere here who can capture your packets. So we need the packets secure. To do that, we have something which is called cryptography techniques. So what is cryptography? It is the process of securely sending the information and receiving the information back between a source and destination in the presence of adversaries. Who are the adversaries? You can, in simple words, you can say the hackers who are basically monitoring, who can basically see your information. If I have a certain credit card number, I have a credit card number, let's say whatever the number is, 2345-987.
Yeah, really, doctor.
Yes, question?
No question.
Okay. So if you are sending this type of information, whatever the credit card number is, if you send it on an HTTP, simple HTTP protocol based website, what will happen? Your packet will be just completely open. If anyone captures your packet, he can simply open it, and he will be able to see your credit card information, your personal information, all of that. So what we do is we use cryptography techniques to secure the information. HTTPS secures the information before we send it on the network. So one of the cryptography technique is called encryption. So what is encryption? It is the process of converting your information that you want to send into a code, a coded message that is called a ciphertext. And then we send it on the internet. So for example, if this was my credit card number, when I encrypt it, when I'm able to encrypt this message the message will become scrambled. What do I mean by scrambled? I will get something like this. This will be the message that will be sent on the internet. Even if someone captures my packet and opens it, he will see this information. Yeah, he will see this information and he will not be able to make sense of it. That is a ciphertext, a coded message. Do you get that, everyone?
Yes.
Doctor, can
The general
anyone do
idea
it?
is, huh?
Can anyone do it?
Yeah, everyone is doing this encryption. So well, let me explain a little bit more. So how this information is converted into this cipher or coded message? It is done through encryption. And similarly, on the other end, on the destination side, we need to do the opposite. We need to convert that coded message back to the original message. And this is done using what is called encryption function and something which is called a key. We plug the key with the function. Function and key, they are basically, they are like together. They are working together to generate an encrypted message. To understand that, I have a very simple example. Let's say I have a data, PYP computer networks. I want to send it on the internet. And here the key is 3 characters. Add 3 characters. And my function is to change each letter of this data according to the key. So what I will do is, for example, P, what is the third character after P? Q, R, S. So P will be replaced with S. Y, the next character is Z, and then we can rotate. This will be part of the algorithm that, okay, should we rotate or should we go backward? Should we go forward in case of we reach the end? That will be written in the encryption algorithm. If let's say we rotate, then after Y we have Z, then we have A, then we have B, third character. So Y will be replaced with B. Then again P will be replaced with S. In some algorithms we have multiple keys, and the algorithm can say that, okay, if there is a second occurrence of the same character like P and then we have P again, then maybe use the second key. And then what to do about spaces? It can be provided in the algorithm. What should we do with the spaces? Here I'm just assuming nothing to do with the space. Just keep the space as it is. And C, what will be the third character after C? D, E, and F. So C will be replaced with F. O is replaced with R, M with P, and so on. This is the ciphertext which is generated. And now I send this text on the network. I send it on the internet. And then when it is received on the destination, they will apply the key again in the reverse order. Do you understand that, everyone?
Yes.
Okay. So that is your encryption. And that is called a private key encryption. In this type of encryption, both the keys must be same to encrypt and to decrypt. If someone gets access to the key, if let's say the hacker gets access to the key, what will happen in that case?
You will know how to solve the encryption.
Exactly. So if I'm a hacker and I opened a packet and it contains this, so what I will do is I can try a brute force attack. In brute force attack, what I will do is I will try to plug different keys. I would plug different keys +3, -3, +2, -2, things like that. I will plug different keys to get some sort of a message from that packet. Once I find the key, in that case, it will be, the whole message can be decrypted. So there are many types of encryption. Private key, public key, in which the source and destination can have the same key. They can have the different key to increase the security. So encryption and cryptography is a complete master's or PhD level course in which we discuss all these different type of encryptions and how we can make them better. Is it okay, everyone, with the encryption idea?
Yes.
Okay. So that was encryption, and encryption is a two-way communication. That is, we encrypt at one end. On the other end, we can also get the same information back in its original format. We say it is a two-way technique. We can get the ciphertext, but we can get the original text back using the opposite way. So it's a two-way method of cryptography in which we can get a coded message and then we can get the original message back by doing the decryption method as well. So it's a two-way algorithm, you can say. But there's another type of cryptography that is called hashing or cryptographic hash. That is a one-way street only, a one-way conversion method. So what is cryptographic hash? It's an information. If I have some text, a hash function is applied on the text to convert it into a digital signature. We call it the hashed text. What's the property of this hashing or this hashed text? The property is that this information is, let me write it here, irreversible. I cannot get the original text back from the hash text. What's the point? Anyone? Why do you think we, for example, yeah, let's see here. If this was my message, let's say Mohsen, but I wrote my name. I put my user ID. And when I pass it through a hash function, for example, the SHA-256, it's a hash function. So if I pass it through that, it will generate this code, this hash code. But the thing is, we cannot, if I give this hash to someone, he cannot generate the original, he cannot know what the original data was. So what's the point of hashing? Any idea? It has a very interesting use, but I will let you guess first. Anyone? What do you think? Where we will use hashing? Yes.
So the receiver has a program that unlock the things.
Unlock. You're close. It's basically, now listen carefully, everyone. This hashing, it is used in Bitcoin or blockchain networks, but that is a little advanced. To make it understandable for you is that it can be used to store passwords on websites, on the website databases. What does it mean? Let's see. For security, let's see. Everyone listen carefully now. Let's say a website has 10,000 users. Okay. Now, to store the user information, not the actual information, just like their username and passwords. That okay, I have these users and these are their passwords. One method, the old method, is to put the user ID and passwords in text file. The problem in this method is that if someone hacks into a website server, what will happen?
He will see your information.
Yeah, you may have heard that if you check the IT news on Google or any other website, you will see that sometimes the websites, they have security breach. The user information is leaked to the internet. What happens basically is those websites, they were storing their users' ID and passwords in simple text file. And when someone hacked into the server, they were able to just get the user ID and passwords. So that's a security risk. So nowadays, hashing is very important for storing the password. So what we do is, in hashing, to store the passwords on the internet or on websites, what they will do is they will ask you to go through the hash function first. When you provide a user ID or create an account with the user ID and password, they will pass that user and ID and password through a hash function. Like I showed you in this on the website, like this SHA256. So let's say I provided that my ID is Mohsin, but my password is, let's say, 123456. Although never use this type. The property of the hashing is that for whatever type of data you have, it will always generate a unique and fixed code, a fixed hash code. So let's say I have this Mohsin Bhatt and this is the password. So this hash code can only be generated with this data. It is unique. So what I will do is, when I'm creating the account, the website will generate the hash for my username and for my password. So this hash basically now it will be stored on the website server, not in the text file, not the simple text of ID and password. Now the hashes will be stored on the website. So what will happen when you want to log in? When you want to log in, you will provide your ID and password. It will go through the hash function, let's say SHA256, and then this hash will be searched in the website server. On the website server, we will just match the hash which is generated. That is the hash text which is generated. So for that user ID and password, only a one unique hash can be generated. And once again, the main property was that it is reversible. Sorry, irreversible. That means even if someone gets or hacks into the website, he will see all the hashes of different users and their password. He will see a list of hashes. And the property of hashing is that from the hash, you cannot convert back to the original data. You cannot do that. So that is why this hashing is very popular for storing the passwords on the servers. Blockchain networks, they also use this hashing technique. It's very, very important. And in the future, you will see a lot of networks, they will start using blockchain networks. Not Bitcoin. Bitcoin is like a currency, but the network behind Bitcoin is blockchain networks. It is also using this cryptographic hash and forming chains of this hash, which makes it very hard to break. Banking systems will start using this blockchain networks very soon to store their users' information. Instead of putting the users' information in simple ID and password format and write down that, okay, this user account has this much balance, account balance is blah, 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 whatever the balance is. So instead of storing this information on the website, they will generate the hash and put that hash in a blockchain network. So in a blockchain network, basically multiple blocks are generated based on multiple users' data. So this is, let's say, user 1, and his password is whatever the password is, and he has, let's say, account number, account balance is whatever the balance is, and then we have user 2, and then we have some data for user 2, and they are all connected with each other to form a long chain, and that is impossible to break. That's why the blockchain networks, they will be used in the future also, so they are also very popular. But at the basic level, let's stick to this hashing. That is, it will convert the text into an irreversible hashed text message that cannot go back. And we just store the hash text. Whenever we receive user ID and password from a user, if he wants to log in, we just pass it through the hash and check, is there a hash text matching that in our database or not in the server. So hashing is also very popular, and the advantage is, even if someone hacks into the server, he will only see the hashed text of all the accounts, and he will not be able to reverse. He will not be able to get back the original ID and password just from the hash text. Is it okay?
Yes,
Yes.
it is okay.
So this is hashing. So this is also very commonly used. So the last section of this presentation is a very simple one. So how can your privacy be affected online? It can be through identity theft, when someone basically steals your information without your knowledge. How can that happen? How can identity theft happen? We have seen all these different methods. So how do you think identity theft can happen? How can someone get your ID card or your credit card number on the internet?
Viruses, maybe, and Trojan horse.
Viruses through Trojan horses, yes, or
Or
sending the information on a website which is not encrypted properly, which is not using HTTPS. You send your credit card number on non-secure websites. In older days, when we didn't have HTTPS, the credit cards, they were stolen in large number on the internet. Internet was not considered secure for e-business, for purchasing items online. It was very bad situation before this encrypted websites, encrypted transfer of information. So that is identity theft. But sometimes you can provide your personal information willingly. That is through what is called scams. People can trick you into revealing your personal information. You can get email from ITC that, okay, we are upgrading our servers and kindly provide us with your ID and password and all the personal details. So always remember, any organization, they will never ask you for the password through emails. So please be aware, read the contents of whatever you are getting carefully before you open them. These are called phishing scams. For example, this was a scam that I reported a few in last year. We received this email. It was sent to me. It says Deanship of Research. The KFUPM Deanship, their address is dr-kfupm. So the starting part is same, but at instead of KFUPM, we have this different domain here. So that's a straight away, that's an alarm that, okay, this is not an actual email from the deanship. The rest of the content, they look exactly like how the email will be from the deanship. This file, the file attachment, it can contain a virus, it can contain a Trojan inside, it's possible. Also, The scam can be that, okay, apply for your application here. If you click on it, it will take you to a fake website. You will provide your user ID, KFUPM ID, KFUPM password, your details, everything. And that's how your identity theft can happen through these scams. Virus hoax, they can send you email that, okay, there is a new virus that is affecting KFUPM. Please download the attachment to scan your computer for that virus. So instead of scanning, you will actually be infected with that virus. Do you get the idea, everyone?
Yes.
Yes.
So once again, you have to be careful. You have to be careful when you are accessing these things online. Now, the last section of this course, this is very simple. That is intellectual property. What is intellectual property? It's a property which is created through your intellect. Companies, they have created, for example, table or chair that you can purchase and then own it. You can say that, okay, I have purchased, I have paid money for that property. That is your physical property. But what is intellectual property is the one which does not have any physical format. For example, you thought of a new mobile game or a new mobile software, mobile application. Now you want to sell it. You want people to purchase that application. But that application doesn't have any physical form. It's your intellectual property. And it's your right that no one else is allowed to copy your material. No one else is allowed to make money from the intellectual property that you created through your mind. So intellectual properties are basically your ideas, music you think of, the art, the photos that we take at different angles. Oh, that's our imagination, how to take the photo at what angle, and if someone wants to use that photo, they should pay us. Movies, programs, the applications that we create, games, they are all intellectual properties. To protect them, we have different laws for different type of intellectual property. For example, we have trademarks. Trademarks are used to protect the company logos and their names. For example, Nvidia, Intel, AMD, HP, all these company names and their logos, they are protected by trademarks. Another company cannot use the logo of a different company. It's not allowed. They can file a lawsuit that, okay, you are copying our logo or like that. So company names and logos, they are protected by trademarks. Similarly, we have something which is called patents. Patents are used to protect the design of new inventions. For example, you want to design a new smartphone. Let's say you are thinking of the design. You will decide, okay, what is the thickness? Okay, what will be the height? What will be the width? What will be the material on the back? What will be the material on the front? Where will the volume rocker be? Where will be the power button? Where will be the charging port? Where will be the speaker placement? Where will be the front camera placement? Where will be the back camera placement? What will be the design of back camera? All of that is part of the design of the invention. That will be protected by patents. Light bulb design, that is also protected by a patent. Different animation studios like Disney or Pixar, when they design a new character for an animation, later on different toy companies will make toys from that particular design, whatever character they designed. So those companies will have to pay the parent company, the actual company who basically filed the patent. So it's very important, whenever you think of some new invention, you must patent the work. Otherwise, someone else can just steal your idea. They can look at it and they can see that, okay, this idea is not patented. They can file a patent and then they will have the ownership right of your idea. So you have to be very careful and quick whenever you think of some new idea, some new way to provide some new invention. You have to be smart to quickly patent that idea. Then we also have what is called the copyright laws. So all the remaining intellectual properties like games, movies, softwares, they are protected by copyright laws. And they use different methods. Licensing, for example, softwares, Microsoft Office, if you purchase it, you will get a license number. Games, if you purchase online on Steam or any other store, you will get a key that you can use to activate that particular game. That key is unique to your account. You paid for it, you purchased it. So those are copyright laws. And what is piracy? Opposite. Accessing someone's intellectual property without payment, without paying him the actual money that he set forth. And once again, most of the pirated content, it can contain trojans inside it, so you have to be careful. As for students, we have something which is called plagiarism. You should also be aware of that. When you are writing reports, later on, when you will have different projects in the freshman or later years, you will need to write reports. But please do not just copy paste. That is plagiarism. Failure to cite the source or pretending it is your own work. Normally what you do is when you have to write a report, you will go to Google, you will search for the material. You will get material from different websites. This is fine. You can go to multiple websites, but do not just copy paste the material. Don't do that. All the university faculty, we have access to plagiarism checking softwares. We just upload your report and we can see that, okay, how much percentage was copied, from which location it was copied, get the full report. So what's the proper method? If you want to write a report, what do you think? What should be the proper method? Anyone?
Change the words and put
Change the
the
word, or
reference.
basically, yeah, how we can say that is after reading, okay, open all the material that you have. It's fine to have a lot of material, that's okay, but you read it and then write the report in your own words. Whatever you understood, write it in your own words. Even that is not enough. After writing it in your own words, you have to provide a reference chapter also. In references, you will write down the number that, okay, I got the source material from this location. I have to write down all the references. And then your work will be considered legitimate. It will be considered proper. For example, if I have a paper like that, I'm writing in my own words. And if I'm summarizing something from a different source, so here, for example, this sentence I have written, prolonging the network lifetime under a strict temperature constraint was addressed in this. So I'm summarizing the work done in a certain report. So I will provide a reference here by writing the numbers 1 or 2. Can you see it clearly? Let me zoom in. So you write it in square brackets, the references that, okay, I got this sentence from here. This was my source material. Do you get the idea?
Yes.
Write it in my own words. Whenever I need references, I provide these numbers. And then at the end of my report, what I will do is, do you see what I did here? In the end, you need to create a references chapter. where you will write the full detail of those references that were used. Do you get that, everyone?
Yes.
Okay, so for bachelor's level, the level of plagiarism allowed is up to 20%. It may change later, but for now it was 20%. At master's, it's around 15%. So we just pass through the report to the software and it will tell us how much percentage was copied. 10%, 15%, 20%, 25%. Okay, so that's basically the end of this lecture. If you have any question, you can ask me. Otherwise, you can leave. And once again, on Thursday, we will have the midterm exam at 6 p.m. You need to join the session. I will send you the details in a video format so you can easily understand on Wednesday. If you have any question, you can ask me. Otherwise, leave now. Yes.
Doctor, the recording for week 3, I can't find it in the recording.
Week 3, let me check. It should be there. Just check, provide that range. What was that range from?
I can only find
Is that-
from week 4.
Yeah, that's what I'm saying. So what you do is, once again, you go to the recordings. Let me share with you again. So you come to the online classroom area here and first click on these 3 horizontal arrows, go to the recordings, right? You are seeing only the last 4, right?
Yes.
Yeah. So just click on this that says recent recordings. Do you see that filter option?
Yes, it's there.
Yeah, and then change to recordings in a range. And then
Change
the range, the starting value, you change to the beginning of the semester. It was 17th of January, I think, yeah. And then it will show you all the recordings from the first week, second, third, fifth, sixth, seventh, and so on.
Yes, it's clear. And how can I see my grades in the assignments?
Assignment grades, I will update later, maybe at the end of the week. I will check, okay? Don't worry.
Doctor, can you leave?
Yeah, you can leave now, yes. I'll stop the recording.